Alright, we're going to start talking about arithmetic sequences today. Okay? Alright, so it says definition of an arithmetic sequence. An arithmetic sequence is a sequence in which each term after the first differs the preceding term by a constant amount. The difference, meaning subtract, between consecutive terms is called the common difference of the sequence. The common difference D is found by subtracting any term from the term that directly follows it. Okay, so in the following examples, the common difference is found by subtracting the first term from the second term. In other words, a sub 2 minus a sub 1. So here, there's my a sub 2. 146 minus 142 is 4. This is changing by 4 every time. They're adding 4 to get the next one. Add 4 gets the next one. Add 4 gets the next one. So the common difference is adding 4. Okay, we'll get to geometric sequences, which you can follow a multiplication or division pattern. Okay, for this one, -5 and -2, if I take -2 minus a -5, that double negative turns positive, and you get a common difference of 3. Add 3 is -2. -2 plus 3 is 1. 1 plus 3 is 4. 4 plus 3 is 7. They're adding 3 every time to get the next term. Okay, these two, 3 minus 8 would be -5. This one is decreasing, so they're subtracting 5 every time. 8 minus 5 is 3. 3 minus 5 is -2. -2 minus 5 is -7. -7 minus 5 is -12. Okay, so finding the common difference is pretty much the key to working with arithmetic sequences, and all you do is subtract any two of the terms, really. I mean, I could do these two. 158 take away 154 is 4. Okay. Okay, what you need to understand about arithmetic sequences, if it's truly arithmetic, when you graph the terms, you will get a linear, if you connected the dots, you will get a linear function. Okay? If you look at here and you're going, well, where's the ordered pairs, miss? Remember, this is the first term. This is the second. I should put it on top. This is the first term. This is the second, third, fourth, fifth term. So all they're doing to plot these points is they're plotting 1, -5. Second term was -2. Third term was 1. Fourth term was 4. Fifth term was 7. They plotted those points. What you're supposed to see is that the arithmetic sequences are linear functions. Okay, whose domain is the set of positive integers, because you don't do the negative first term and the negative second term and so on and so forth. Okay, it says if the first term of an arithmetic sequence is a sub 1, each term after the first is obtained by adding d, the common difference, to the previous term. This can be expressed recursively. Recursively means you're using the term in front of it to get the next one. So if you want the next term in the sequence, you take the term in front of it and you add the common difference to it. And to use this, you have to be given the first term. Alright, so it says, write the first 6 terms of the arithmetic sequence in which a sub 1 is 6. And here's your recursive formula. It says to find the nth term, you take the 1 in front of it and subtract 2. Okay, so I already know a sub 1. So to find a sub 2, I take a sub 2 minus 1 minus 2. 2 minus 1 is a sub 1. A sub 1 is 6. So 6 minus 2 is going to be a sub 2, which is 4. So I have 6, 4. To get a sub 3, that's going to be a sub 3 minus 1 minus 2. 3 minus 1 is 2. A sub 2 is 4. 4 minus 2 is 2. So a sub 3 is 2. A sub 4 will be a sub 4 minus 1 minus 2. 4 minus 1 is 3. A sub 3 is 2. 2 minus 2 is 0. So the fourth term would be 0. And guys, I mean, I'm doing all the algebra just so that you can see, you know, you need to be comfortable with these subscripts. But once you get the first one and you know the common difference is subtracting 2, 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is 0. I mean, this is just fancy show your work type thing, but once you know the first one and you know the common difference, just start subtracting it and keep going. Alright, fractions, not so easy to do in your head, but it says write the first 5 terms of this arithmetic sequence. They're telling me that I'm starting with negative 2/5. This recursion formula tells me that the common difference is negative 1/5 because it says subtract 1/5 from the term in front of it. And keep doing that to keep extending out the sequence. Okay, so without doing all the math, if I start with negative 2/5 and I subtract 1/5, that's going to be negative 3/5. If I subtract 1/5 from that, that's going to be negative 4/5. If I subtract 1/5 from that, that's going to be negative 5/5. And then there's your, first 5 terms, 1, 2, 3, 4. So then if I subtract 1/5 from that, I get negative 6/5. Now, if I was writing my answer out, if I could reduce or simplify these fractions, I would. Like this one, I can write as negative 1. So my solution would be negative 2/5, negative 3/5, negative 4/5, negative 1, and negative 6/5. That would be the first 5 terms of my arithmetic sequence. Okay? Alright. Let me just show you one. So if I did a sub 2 showing all the math, it'd be a sub 2 minus 1 minus 1/5. A sub 2 minus 1 is a sub 1. A sub 1 was negative 2/5 minus 1/5 is negative 3/5. And there's the second one. And then you do a sub 3 would be a sub 3 minus 1 minus 1/5. This would be a sub 2. A sub 2 was negative 3/5 minus 1/5 is negative 4/5. A sub 4, so on and so forth. Okay. Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got one. Alright, so this says start at negative 20 and subtract 3. So negative 20 minus 3 would be negative 23. Minus 3 would be negative 26. Minus 3 would be negative 29. Minus 3 would be negative 32. Like I said, you can do all the fancy math if you want to, but in a recursive formula, it's saying take the previous term and subtract 3. So they're telling you the pattern is to subtract 3 every time. Okay, try this one, hit pause, come back when you're ready. And it says start at 5/8 and subtract 1/8. So minus 1/8 would be 4/8. Minus 1/8 would be 3/8. Minus 1/8 would be 2/8. Minus 1/8 would be 1/8. And then they are going to simplify this. You can't reduce 5/8. 4/8 reduces down to 1/2. I can't reduce 3/8. This reduces down to 1/4, and I can't reduce 1/8. Pretty easy? Alright, so what does the graph of an arithmetic sequence look like? A line. It's linear. Always. If it's arithmetic, when you graph it, it will look linear. Alright, so now what if we wanted to find the general term of an arithmetic sequence? It says, consider an arithmetic sequence whose first term is a sub 1 and whose common difference is d. We're looking for a formula for the general term a sub n. Let's begin by writing the first 6 terms. The first term is a sub 1. The second term would be a sub 1 plus d. Then you'd add 2d's, 3d's, 4d's, 5d's. And that's if you know the first term. Okay? So what we can simplify that down to, for example, if I have these numbers, okay, first thing I would do is find d. So you would subtract, right? Is 2. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. 12 minus 10 is 2. 14 minus 12 is 2. So the common difference is 2. They're adding 2 every time. Okay, so if I show the pattern above, right, there's my 4. 4 plus 2 is 6. 4 plus 2 times 2 would be 4 plus 4 is 8. 4 times 3 2's would be 10. 4 times 4 2's And notice, this was in your first position, second position, third position, fourth position, fifth position, sixth position. So notice that because you're starting in the first position, here for the second term you're adding 1 copy of D. For the third position you're adding 2 copies of D. For the fourth position you're adding 3 copies of D. For the fifth position you're adding 4 copies of D, because it's not just going to be 5 copies of D, because you got to start with wherever you started. Okay? So, if I do that, right, if I compare the coefficient of D and the subscript of A denoting the term number, can you see that the coefficient of D is 1 less than the subscript of A denoting the term number? Okay, like I said, this would be A sub 1, this would be A sub 2, this would be A sub 3. See how that's 1 less than that? A sub 4, 3 is 1 less, A sub 5, A sub 6. Okay, from that, then we can come up with some rules. Okay, if you want the third term, you're going to take the first term and add 2 common differences to it. Because to get the third position, you take the first one plus 2 more. Okay, if you're looking for the fourth term, you take the first term and you're going to add 3 common differences. Because to get in the fourth position, you have the first term plus 3 copies of the change, right, to get to position 4. Okay? So the formula to find the nth term, or in other words, where you don't have to write, before they just said like write the first 6 terms. Well, that's not hard, but what if they just give you a sequence and say find the 10th term? I don't really want to write out the pattern for 10 positions. So we have a formula. If you're looking for the nth term, you take the first term and you're going to add n minus 1 copies of D. In other words, if you're looking for the 5th term, you're going to add 4 copies of the common difference to the start, and that will get you to the 5th position. Adding 4 common differences would get you to the 5th position. Alright, so there's my formula. If they want you to find a specific term, plug in n and a sub 1 and solve. If they want you to write a formula for the general term, you're going to have to find your D and your first term and plug them into this and then simplify it down to a linear function. And then to use a formula to find a specific term is the same as up here. I don't really know why I repeated myself. Alright, so it says find the 8th term of the arithmetic sequence whose first term is 4. So they're telling me a sub 1 is 4 and the common difference is negative 7. Alright, so we want to find the 8th term, which means n is 8. So we're plugging in to a sub n equals a sub 1 plus 8 minus 1 common differences. Yeah? So if I do that math, the 8th term will be 4 plus 7 times negative 7. So the 8th term is going to be 4 minus 49. So the 8th term would be negative 45. Done. Okay. And this one they want me to find a formula first and then use it to find the 20th term. Alright, to find a formula, we have to find the common difference. So 10 minus 19 would be negative 9. 1 minus 10 is negative 9. Negative 8 minus 1 is negative 9. So my common difference is negative 9. Then it says find a sub 1. Well, that's easy. It's the first number in the list. So a sub 1 is 19. Then it says plug those two into my formula. So I have a sub n equals a sub 1, which is 19, plus n minus 1 times negative 9. Right? And now if I simplify this, I would get 19 minus 9n plus 9, because I distribute. Combine like terms, and to get the nth term, I would take negative 9n plus 28. There's my formula for the nth term of my arithmetic sequence. So now I'm going to use this formula to find the 20th term. So a sub 20 is negative 9 times 20 plus 28. That's going to be negative 180 plus 28. Negative 180 plus 28 is negative 152. The 20th term here is negative 152. And you could have just kept going. First, second, third, fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But do you want to keep doing minus 9, minus 9, minus 9, minus 9, negative 17, minus 9, oops, negative 17, minus 9, dang it, Hazel, negative 17, minus 9, negative 26, minus 9, negative 35, minus 9, negative 44, minus 9. I mean, you can keep doing that, but again, a formula is going to be much, 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 much faster. All right. It says write a formula for the general term, or the nth term of the arithmetic sequence, then use the formula to find the 20th term. Again, when they give it to you like this, I have to find D. Well, they didn't give me a series of numbers. If they're giving it to you this way, remember this is the recursion formula, which says to get the next term, you take the first term or the previous term and subtract 7 for it. So it's telling me my common difference is 7, right? Subtracting 7. Okay, and I know a sub 1 is 32. So I got that. I'm going to plug them into this formula. So I have, oops, sorry, hold on. So I have a sub n equals a sub 1 plus n minus 1 times negative 7. Okay, and at this point, you could plug in 20 right now and find it. You're going to take the first term and add 19 common differences to it, right? But we can simplify this. And we have a sub n equals 32 minus 7n plus 7. Combine like terms, I get a sub n equals negative 7n plus 39. There's my formula. And now to find a sub 20, I'm going to change n to 20. So negative 7 times 20 plus 39 is negative 140 plus 39, which is negative 101. The 20th term will be negative 101. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 3. Alright, so I have to find the common difference. Negative 20 minus a negative 13 would be negative 7. Negative 27 minus a negative 20 would be negative 7. So my common difference is negative 7. My first term is negative 13. Plug them in my formula. I get a sub n equals a sub 1, which is negative 13, plus n minus 1 times negative 7. So if I simplify that, and again, you could find the 20th term right now and take the beginning and add 19 common differences. But they want me to simplify this, make it a prettier equation, so I have negative 13 minus 7n plus 7. Combine like terms, and a sub n equals negative 7n minus 6. That's where they got this. Now to find the 20th term, I find a sub 20, negative 7 times 20 minus 6, that's negative 140 minus 6, which is negative 146. Okay? Alright, hit pause, come back when you're ready, and hopefully you got 2. Alright, here they gave me the recursion formula, which tells me my common difference is 6. My first term is 18. Plug them in here. A sub n equals 18 plus n minus 1 times 6. Simplify it. I have 18 plus 6n minus 6. Combine like terms. A sub n equals 6n plus 12. And to find a sub 20, I take 6 times 20 plus 12. That's going to be 120 plus 12 is going to be 132. Okay? Alright, it says, for the following arithmetic sequence, find A, the common difference. To do that, you subtract terms. So -2 minus a -6, double negative terms, that's positive. 2 minus a -2 turns positive is 4. So my common difference is 4. Okay, they want me to find a recursive rule for the nth term. Okay, so I'm going to plug D into this, and I would get my A sub n is A sub n minus 1 plus 4. In other words, the common difference is 4. To continue the sequence, you add 4 to the previous term, and you keep going. That's your recursive rule. Your explicit rule, you basically plug in your A sub 1 and D, right? And then simplify it down to slope-intercept form. So, I know that my D is 4, and I know that my A sub 1 is -6. So, A sub n will be -6 plus n minus 1 times 4. Simplify that. You have -6 plus 4n minus 4. You get A sub n equals 4n minus 10. There's my explicit rule, my general rule. And then to find the 10th term, I'm going to find A sub 10, which would be 4 times 10 minus 10, which would be 40 minus 10, which would be 30. The 10th term of this sequence would be 30. Okay, so do you see the difference between your recursion rule and your general rule? Okay. Recursion always has to have A sub n minus 1 in it, always, or it's not recursion. Because recursion means it's finding the next one based on the last one. Alright, so this one, go ahead, you find an explicit rule for this one. That means simplify it. Hit pause, come back when you're ready. Alright, so to find a general term, you need A sub 1 and D. So A sub 1 is 15. To get my D, 26 minus 15 is 11. 37 minus 26, yep, D is 11. So if I plug those in, A sub n equals 15 plus n minus 1 differences. And if I simplify that, actually they didn't simplify that. They left it 15 plus 11 times n minus 1. They just put the 11 in the front. Okay, I would have simplified it and got 15 plus 11n minus 11, combine like terms, 11n plus 4. That's my explicit rule. Alright. Using an arithmetic sequence to model changes. It says the graph in figure 11.4 shows the percentage of U.S. population by race ethnicity for 2010, with projections by the U.S. Census Bureau for 2050. The data show that in 2010, 64% of the U.S. population was white. On average, this is projected to decrease by approximately 0.45% per year. It says, write a formula for the nth term of the arithmetic sequence that describes the percentage of U.S. population that will be white n years after 2009. Okay. So we need a common difference and we need a starting point. Well, it's starting at 64%, and the common difference is it's going down by 0.45% every year. Okay? So to write my explicit formula, I have A sub n equals A sub 1 plus n minus 1 times negative 0.45. So A sub n equals 64 plus, actually minus, because a negative times a positive is negative 0.45n, a negative times a negative is positive plus 0.45. So I have A sub n equals 64 plus, so that's going to be negative 0.45n plus 64.45. Okay? So there's A. B says, what percentage of the population is projected to be white in 2030? Well, 2030 is how many years after 2009? Subtract 2030 minus 2009. 2030 minus 2009. 21 years. So they want me to find a sub 21, which would be negative 0.45 times 21 plus 64.45. So if I type that, negative 0.45 times 21 plus 64.45, and you get a sub 21 is 55. So by the year 2050, they're projecting only 55% compared to 64% will be white. Alright, so it says, to train for a race, Will begins by jogging 15 minutes one day per week. He increases his jogging time by 5 minutes each week. Write the general term of this arithmetic sequence and find how many whole weeks it takes him to reach a jogging time of 1 hour. Alright, a sub 1 is he's starting out at 15 minutes. The common difference is 5 minutes each week. Okay, so my a sub n would be my a sub 1 plus n minus 1 d's. So a sub n equals 15 plus 5n minus 5. So a sub n equals 5n plus 10. Okay, so now I want to figure out how many weeks is it going to take for him to reach a jogging time of 1 hour. So I want to know, when will this pattern give me 60 minutes over here? Okay, so to solve that, I would minus 10, I get 50 equals 5n, divide by 5, divide by 5. It's going to take about 10 weeks, and he'll be up to jogging an hour every day per week, or an hour 1 day a week. Alright, so you try this one. Hit pause, come back when you're ready. Alright, and hopefully you get 33,421. Okay, it says the population of a town is increasing by 500 inhabitants each year. That's your D. Its population at the beginning of 1990 was 29,421. So that was my a sub 1, 29,421. Yeah? So if I write my recursive, or my general formula, a sub n equals a sub 1, 29,421 plus n minus 1 d's. Distribute, I get 29,421 plus 500n minus 500. That gives me 500n plus 29,421 minus 500 is 28,921. Okay, so there's my a sub n. Now, it wants me to figure out the population at the beginning of 1998. Well, I need to know how many years after 1990 that was, which would be how many years? 8 years. Right? 1990. Yeah. So I want to find a sub 8. So I'm going to have 500 or is it 9 years? Because you got to count all of 1990. 1990, then 1991, 92, 3, 4, 5, 6, 7, 8. That's 1, 2, 3, 4, 5, 6, 7, 8. That's a total of 9 years. Aha, that's why I put this here. It's 9 years because you got to count the whole year of 1990 too. So I'd have 500 times 9 plus 28921. 500 times 9 plus 28,921. There we go. 9 years later, the population will be 33,421. Alright, so how do you write a recursive formula for an arithmetic sequence? That's when you do the a sub n equals a sub n minus 1 plus d. The explicit formula is a sub n equals a sub 1 plus n minus 1d. And how do you write a function that describes the relationship between two quantities given in an arithmetic sequence? Well, you have to find a sub 1 and d and plug in two equations and simplify. Alright, a little bit of homework help. It says, write a formula for the general term of the arithmetic sequence whose second term is a sub 2 and whose sixth term is 16. Again, to write a formula, I need a sub 1 and I need the common difference. So, they didn't give that to me. 2, 3, 4, 5, 6. What they gave me is the second position is 4 and the sixth position is 16. Well, I know I've got to get there by adding something. So plus something, plus the same something, plus 3 something has to equal 16. So 4 plus 3 common differences has to equal 16. Does that make sense? Starting at 4 plus 1 difference, 2 difference, 3 differences has to come out to 16. So if I solve that, minus 4, I get 3d equals 12, divide by 3, and d equals 4. And let's see if it works. Okay, take away 4, this would be 0, add 4 is 8, add 4 is 12, add 4 is 16. Nope, and 1 off. Fourth, fifth, oh, because I can count. No, second, third, fourth, fifth, sixth term. Well, that didn't work very well. Why isn't it working? 4 is 8, plus 4 is 12, plus 4 is 16. It's got to be 4 plus d plus d plus d plus d would give me this term, plus this d gives me this term, plus d gives me this term, oh, plus another d gives me this term. Yeah, I'm sorry, I forgot, you'd have to add another d to get to that one. So it's actually 4 plus 4d equals 16. My bad. So minus 4, then divide by 4, and you get d equals 3. Let's see if that works. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16. There we go. And minus 3, this would be 1. So your common difference is 3. Okay, and my first term then is 1. So to get your rule, you would say a sub n equals a sub 1 plus n minus 1 times 3. Distribute, I get a sub n equals 1 plus 3n minus 3. That gives me a sub n equals 3n minus 2. That would be my rule for that arithmetic sequence. Alright, so we are at homework, which means we're done. So happy homeworking, and I will see you next time.